Let's jump here into Chapter 5. Chapter 5 covers the basics of functions. So up to this point, what we've been messing around with is sort of iterative programming, where we start at the top, we go down, line by line by line. Sometimes we have a loop, sometimes we may not, but everything sort of executes from the top to the bottom of the Python file. Now, again, if we want to take input, if we want to do anything that requires a lot of repeated code, we just have to write the code over and over and over again. Well, the best way to solve that issue of sort of writing the same code over and over again is by using these things called functions. Now, again, we're no stranger to what functions are. We've been using the input function, we've been using the print function, and we've been sort of playing around with this idea of reusable code. Now, obviously, the input function we know takes into itself a string. And what it does is it takes keyboard input and then it returns a string of keyboard input from the user. Okay, so again, going back to sort of the input processing output paradigm, we can actually model functions just like programs. You have some sort of an input, you have some sort of an internal processing, and you have some sort of an output. Okay, so that's what we're talking about when we mean functions. It's a lot like an algebraic function. There's some sort of an input, there's something that happens to that input, and then there's some sort of an output. Okay, so like, for instance, in terms of input validation, we can actually create an input validation function rather than actually writing the input validation over and over and over and over again every time a user enters some sort of an input. Instead, what we can do is we can write this single function, and every time a user enters input, we actually send the user into that function, and that function handles the validation of their input and then returns their valid input. And I will show you how to do that later. But that's just one of the very many functions of functions, right? It's the purpose of functions. So going through this, we're going to be hitting a lot of different types of functions. We're going to have an introduction to functions. We're going to have defining and calling void functions, programs to use functions, local variables, global variables. We're also going to have value returning functions. And then we're going to introduce you to the math module, which is the generation of random numbers. We're going to be using the random integer function there inside of that module. And then if we have time, we'll actually go in and talk about storing functions in modules as well. All right, so jumping into this, again, I kind of conceptualized in the introduction there what a function is, okay? But the official definition, according to the book, is a group of statements within a program that perform as a specific task. So in previous videos, I've talked to you about, we're on a construction site. We're building this house, and I need to hammer in a nail. Well, the function of the hammer is the same every single time that I use it. I pick it up and I hit the nail until the nail is all the way in. Okay, so every time I need to hammer in a nail, I can use the same hammer over and over and over again. You could consider the striking of the nail as the input and the nail going down as the output, and the hammer providing the energy to move that nail as the processing. Okay, it would be silly for me every time I want to hammer a nail in to get a different hammer or to make a new hammer, right? I could just make the hammer, use the hammer over and over and over again. Okay, so that's what they mean by this group of statements within a program that perform a specific task. Okay, so like I mentioned earlier, input validation can be that specific task. So again, this is part of the abstraction concept of designing a program, where you want to sort of break it down into very, very niche little tasks and then solve those with different functions, right? Like use a function that defines area, use a function that validates input, use a function that formats output. You can kind of set that all out. Use a function that gets a certain value from a file. Use a function that opens a file and returns the file. So you have a bunch of different little functions. Now, when you sort of put them all together, it's sort of like building a house, right? You have a nail gun, and you have a hammer, and you have a circular saw, and you have a chop saw, and you have all these different tools that you use to build this house. Okay, so officially, what this sort of design paradigm is called is divide and conquer, where you divide up all the functions of the program into smaller pieces, and then those pieces can be combined together, sort of like Lego blocks almost, to make the final program. Now, the nice part about that is it makes the program much more readable, because it breaks it down into little chunks. And again, I'll show you what that sort of looks like. It also makes it way easier to test, because I can lift out one of those functions and I can create a testing framework that gives it input, it tests its processing, and then it monitors the output. Now, what this means is, as we're sort of creating these programs that use functions, there's a specific term that we use, and that is a modularized program. Okay, so a program wherein each task within the program is in its own function. So if you see a program that is not modularized, it's basically what we've been doing up to this point, where it just starts at the top, goes to the bottom. Boom, that's it. Okay, so what we're going to be doing now from here on out, we're going to be creating modularized programs. I don't want to be seeing any of these programs with stuff just on the outside. Okay, so gone are the days of sort of, let me get a Python file here. We're going to just call this chapter 5. Gone are the days where we do this sort of thing, height equals input, enter height, right? We don't want to be seeing it at this level. Instead, we're going to be seeing things tabbed in. And again, I'll demonstrate to you what that is. But I don't want to just be seeing lots of lines of code at this 0 indentation level. So we're going to be creating modularized programs. So the way that this works is you can kind of think about it even like while loops or for loops. It basically changes the function flow, sort of the program flow via the functions. Okay, so as we've been going thus far, the program is just one long sequence of statements, right? It's just statement. To this point, this is how we've kind of done it. We may create loops that kind of break down into these statements, but in general, it just looks like this. If we modularize the program, we create functions, then it starts to look like this. You can see how overwhelming this is. You start at the top and you're just wondering, what is going on? What is going on? At this point, I can actually name these functions with useful names like get area, set area, validate user input, check user input, whatever that might be. And I know sort of, okay, this is going to, validate user input. This is going to get the area and so on and so forth. Okay. So it just looks a lot cleaner. It's a lot easier to read. It's a lot easier to validate. It's a lot easier to test. So again, the benefits that we see again is it's going to be simpler code. If we come back and we look at this, obviously this is really hard to read. This is much, much easier to read. Okay, so you're going to have simpler code. You're also going to have this nice code reuse, because what I can do now is I can use function 1 over and over and over and over and over again, right? I don't need to just write it once and use it once. I can call into it over and over and over and over and over again, and I don't have to continually rewrite the information inside of that function. So we have that code reusability. You can also test it a lot easier and debug it a lot easier. Plus, it's a lot faster in terms of development. Now, when they talk about this easier facilitation and teamwork, basically what that means is I can give, say, to my programmers that are underneath me, I want you to write the input validation loop. I want you to write the check values function. I want you to write the get file function. Okay, so then each person can write the function they're supposed to, and then you can have a separate team for testing that actually creates tests for each one of those functions, and then you can put it all together, know that they all work, and everything's going to work out. Okay, so that's sort of the benefits of using these functions. The detriments can be sometimes it overloads the jumping. So every time you jump into a function, you have to jump to a new address, and if you're using too many functions, you can have a lot of jumps in the execution of your program logic. Okay, so sometimes if it gets too complicated, it can actually reduce efficiency. But in general, the benefits far, far outweigh the detriments of using these functions. So for the rest of this course, I want you as students to be writing functions. I don't want to be seeing stuff on the outside. Okay? All right, so jumping into these functions, we have a couple types. The two primary types that we have are the void function, the value returning function. Void function is kind of exactly what it sounds like. It returns nothing. Void is empty, it's a vacuum, it's a space, it's a nothing. Okay, so a void function indicates that it returns nothing. So it just executes the statements and then terminates. So it's sort of like a print function, right? So if you have some sort of a print function where you send in some values and it prints those values out in a specific format, it doesn't return anything, doesn't do anything, it just prints the stuff out. Okay, that's what a void function. It doesn't return any data back to what called it. Okay, a value returning function. So in terms of the void function, it's IP and there is no output. It's input processing and that's it. Okay, output is nothing. So a value returning function, on the other hand, returns something. Obviously, it's the opposite of the void function. It executes the statements, it does some math, it calculates area, takes some user input, does a bunch of different stuff inside of there, and then it returns some value back to the statement that called it. So say you want to use this input validation loop. Okay, so you call the input validation loop. The input validation loop handles taking the user input, making sure that it's a yes or a no. Once it's a yes or a no, then it will return that yes or no that the user input. Okay, so again, you can also have those sorts of functions, obviously. Now, the input, int, float functions are examples of value returning functions. So input obviously returns a string, int obviously returns an integer, and a float obviously returns a float. So in terms of defining and calling, obviously functions are given names, and you want to make sure that the name means something. Like, you don't want to be naming your function A, B, C, D, or you don't want to name it function 1, function 2, function 3. So like what they did here, this is not necessarily a good name, okay, because I don't really know what that does. So you want to name it with some sort of a useful name, right? And again, in the function naming rules, it's much like a variable. You cannot use keywords as a function name. You can't contain spaces. First character has to be a letter. Other characters need to be a letter, number. Obviously, upper and lowercase characters are distinct. We're using Snake's case, which means we want all lowercase characters, okay, and we want underscores in between words. All right, so we're going to come back on defining and calling a function on the other side of the break. Take a little break, get a drink of water, maybe play around a little bit with what we've got here so far. I mean, it's not a lot of coding yet to do, and then I will see you in the next video.